ಆತ್ಮೀಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ನಾವು ಹಿಂದಿನ ಕ್ಲಾಸ್ಗಳಲ್ಲಿ ಸೀಕ್ವೆನ್ಸ್ ಅಂದ್ರೇನು, ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಎ ಸೆಟ್ ಆಫ್ ರಿಯಲ್ ನಂಬರ್ಸ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ 1-to-1 ಕರೆಸ್ಪಾಂಡೆನ್ಸ್ ವಿತ್ ದ ಸೆಟ್ ಆಫ್ ನ್ಯಾಚುರಲ್ ನಂಬರ್ಸ್ ಅಂತ ನೋಡಿದ್ದೀವಿ. ಆನಂತರ ಟೈಪ್ಸ್ ಆಫ್ ಸೀಕ್ವೆನ್ಸಸ್ನಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಸೀಕ್ವೆನ್ಸ್ ಅಂದ್ರೇನು, ಅರ್ಥಮೆಟಿಕ್ ಸೀಕ್ವೆನ್ಸ್ ಅಂದ್ರೇನು, ಜಾಮೆಟ್ರಿಕ್ ಸೀಕ್ವೆನ್ಸ್ ಅಂದ್ರೇನು, ಬೌಂಡೆಡ್ ಸೀಕ್ವೆನ್ಸ್ ಅಂದ್ರೇನು ನೋಡಿದ್ದೇವೆ. ಅದೇ ರೀತಿಯಾಗಿ ಬೌಂಡೆಡ್ನೆಸ್ ಆಫ್ ಎ ಸೀಕ್ವೆನ್ಸಸ್ ಬಗ್ಗೆ ಸಾಕಷ್ಟು ಮಾಹಿತಿಯನ್ನು ಮಾಡಿದ್ದೇವೆ. ಬೌಂಡೆಡ್ ಬಿಲೋ ಸೀಕ್ವೆನ್ಸು, ಬೌಂಡೆಡ್ ಅಬೋವ್ ಸೀಕ್ವೆನ್ಸು, ಆ್ಯಂಡ್ ಆಲ್ಸೋ ವಿ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ಡ್ about the greatest lower bound of the sequence, upper bound of the sequence, and least upper bound of the sequence. Of course, ನಾವು ಈ ಹಿಂದಿನ ಕ್ಲಾಸ್ಗಳಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದಕ್ಕಿಂತ ಸ್ವಲ್ಪ we recall some of the earlier ideas and then we progress for the remaining discussion. So what is required here? As I told earlier, constant sequence ಅಂದ್ರೆ ಏನಂತ ಗೊತ್ತಿದೆ, where all the elements will represent a single value. All the elements of a sequence represent a single value. We call it as constant sequence. In case of arithmetic sequence, the difference between nth term and n minus 1th term remains constant. For every pair of elements of a sequence, the difference between the element and its preceding element remains constant. ನಾವೇನು ಹೇಳ್ತೇವೆ ಅಂತಂದರೆ, ಫಸ್ಟ್ ಎಲಿಮೆಂಟು a1 ಅಂತ ಹೇಳ್ತೇವೆ, ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟ್ ಈಸ್ a1 ಪ್ಲಸ್ d ಅಂತ ಹೇಳ್ತೇವೆ, here d is the common difference. ಥರ್ಡ್ ಎಲಿಮೆಂಟ್ ಈಸ್ a1 ಪ್ಲಸ್ 2d, ಫೋರ್ತ್ ಎಲಿಮೆಂಟ್ ಈಸ್ a1 ಪ್ಲಸ್ 3d, and so on. The nth term will be decided in case of arithmetic sequences. In case of arithmetic sequences, the nth term is written as a1 plus n minus 1 into d, where n is the natural number, a1 is the first term of the sequence, and d is the common difference, a1 plus n minus 1 into d. ಅದೇ ರೀತಿ ಜಾಮೆಟ್ರಿಕ್ ಸೀಕ್ವೆನ್ಸ್ನಲ್ಲಿ a1 ಫಸ್ಟ್ ಟರ್ಮ್ ಅಂತ ತಗೊಂಡ್ರೆ a ಇಂಟು ಆರ್ ಸೆಕೆಂಡ್ ಟರ್ಮ್, a ಇಂಟು ಆರ್ ಸ್ಕ್ವೇರ್ ಥರ್ಡ್ ಟರ್ಮ್, a ಇಂಟು ಆರ್ ಕ್ಯೂಬ್ ಫೋರ್ತ್ ಟರ್ಮ್, ಆ್ಯಂಡ್ ಸೊ ಆನ್, ವೇರ್ ಆರ್ ಇಸ್ ಕಾಲ್ಡ್ as ಕಾಮನ್ ರೇಷಿಯೋ. ಅಂದರೆ n plus 1th element divided by nth element, if you take, it will represent r, the common ratio. ಯಾವುದೇ ಒಂದು ಎಲಿಮೆಂಟನ್ನು ತಗೊಂಡ್ರೆ ಇನ್ ದ ಜಾಮೆಟ್ರಿಕ್ ಸೀಕ್ವೆನ್ಸ್, ಅದರ ಹಿಂದಿನ ಎಲಿಮೆಂಟ್ನಿಂದ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ಬರ್ತಕ್ಕಂಥ ಒಂದು ರೇಷಿಯೋ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರ್ತದೆ. ಅದನ್ನು ನಾವು ಜಾಮೆಟ್ರಿಕ್ ಸೀಕ್ವೆನ್ಸ್ ಅಂತೀವಿ. ಸೊ ಇಲ್ಲಿ ಕೆಳಗಡೆ ಒಂದೆರಡು ಎಕ್ಸಾಂಪಲ್ಸ್ ಕೊಟ್ಟಿದ್ದೇವೆ ಜಾಮೆಟ್ರಿಕ್ ಸೀಕ್ವೆನ್ಸ್ ಬಗ್ಗೆ. ಅದೇ ರೀತಿಯಾಗಿ ಯು ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್ nth term of the geometric sequence. As I told earlier, every sequence can be associated with a natural number. A sequence is nothing but set of real numbers associated or having 1-to-1 correspondence with the set of natural numbers. So for every n there will be an nth term in the sequence. But can we write nth term as a ಫಂಕ್ಷನ್ ಆಫ್ ಎನ್, ಎಫ್ ಆಫ್ ಎನ್, ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನ್ ಅಂತ ಅಂದರೆ ಅದು ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಅನ್ನಿಸುತ್ತೆ. ಎನಿಹೌ ಯು ಟ್ರೈ ಟು ಫೈಂಡ್ ಔಟ್ nth ಟರ್ಮ್ ಆಫ್ ದ ಜಾಮೆಟ್ರಿಕ್ ಸೀಕ್ವೆನ್ಸ್, ವೇರ್ ಫಸ್ಟ್ ಟರ್ಮ್ ಈಸ್ √6, ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಈಸ್ 2 into √3, ಥರ್ಡ್ ಟರ್ಮ್ ಈಸ್ 2 into √6, and so on. Similarly, find the nth term of the arithmetic sequence 55, 49, 43, and so on. Of course, as I told earlier, you may note that in case of arithmetic sequence, the difference between elements, subsequent elements, is constant. For example, if you take 55 minus 49, it is 6. Again, if you take 49 minus 43, it is also 6. So the nth term can be written as a1 plus n minus 1 into d, where d, the common difference is here minus 6. The common difference is minus 6. So you can write the nth term of the arithmetic sequence, whether it may be a finite sequence or an infinite sequence. Of course, both the arithmetic sequence and the geometric sequence may be a bounded sequence, that is, it may be bounded below as well as bounded above, or it may be only bounded below sequence but diverge to infinity, or it may be only bounded above sequence. So you can find out a lot of geometric sequence as well as arithmetic sequences. Of course, you can also find the nth term or the missing term in a sequence. If you know the constant difference in case of arithmetic sequence and common ratio in case of geometric sequences. So here there is one such example, that is, does the number 48 belong to the geometric sequence 3072, first number, second number 1636, and so on. So as I told earlier in our previous class, we have discussed about the types of sequences, that is the arithmetic sequence, geometric sequence, constant sequence, and many bounded sequence, and all those things. So here what I am giving you, here I have listed some of the sequences where nth term is given as a function of n. The nth term an is given as a function of n. In the first problem, an is equal to n divided by 1 plus n square. In the second term, an is equal to a log of 1 plus 2 times e power n divided by n, and so on. ಇಲ್ಲಿ ಲಾಗ್ ಅನ್ನೋದು ಟು ದ ನ್ಯಾಚುರಲ್ ಬೇಸ್ ಇರೋದ್ರಿಂದ ಎಲ್ ಎನ್ ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ ಅದಕ್ಕೆ ಯು ಕ್ಯಾನ್ ಫೈಂಡ್ ಔಟ್ ಸಮ್ 10 ಟರ್ಮ್ಸ್ starting from the first term 10 terms of the given sequences, and also try to find out whether these sequences are bounded below or bounded above, or bounded below as well as bounded above, that is whether these sequences are bounded sequences. If possible, also try to find out the greatest lower bound and also the least upper bound of these sequences. So you try to solve these problems. We shall discuss about the limit of a sequence in the next class. But anyhow, I given a small introduction of limit of a sequence. Limit of a sequence is nothing but it is a real number L such that limit of Sn as n tends to infinity must equals to L. So we shall discuss all these things maybe in the next class.